Okay, we're going to talk about inverse trig functions and how to use them. So, the three inverse functions that we are going to talk about is the inverse of the sine, the inverse cosine, and the inverse tangent. They're sometimes written as the function to the -1 power of x, but most of the time they're going to be written as arc sine, arc cosine, arc tangent. That's just more common, and I think that makes a lot more sense. Okay, so these are the domains. For the domains, for the inverse functions, you can only use the angles included within the domain. So that means for the inverse sine, you can only use quadrants 1 and 4. You can only use angles within here. That means you can't use an angle, let's say 2 pi over 3, which would be right about there. You can't use it for the inverse sine. For the inverse cosine, the range is going to be 0, pi. So that means you're going to be able to use all of these right here. And that means you can't use an angle here or an angle here, only in the first and second quadrants. For the inverse tangent, our range is going to be the same as the sine, except it's going to be inclusive instead of exclusive. Okay, let's look at how to use these. So our first example is find the angle for the inverse sine of -1/2. So all we have to do for this is we can just write theta equals, and we just have to look and see where the sine is 1/2. And you need to remember that sine of theta, it's cosine theta sine of theta. So this is going to be our x values, and these are going to be our y values. So we're going to go to the unit circle, yes again, and find where our sine equals -1/2, which is right there. And we cannot put 11 pi over 6 because we cannot enter these quadrants. Okay? So this is going to have to be negative pi over 6. So that's going to be our angle, negative pi over 6. Okay? It's really just that easy. Okay, now we're going to find the angle for the inverse cosine of -1/2. So again, remember it's cosine of theta, sine of theta. Again, for our x's and our y's. And remember, we cannot enter these quadrants. So the only place in the first and second quadrants that the cosine is -1/2 is going to be right there at 2 pi over 3. Okay, so now let's look at a tangent. So we're going to find the angle for the inverse tangent of -√3. So now we need to think about the tangents are going to be negative in this quadrant and this quadrant. But we can't use these two quadrants. We have to use the first and fourth. So we're going to be in the fourth quadrant. Now I need to find where the tangent is -√3. I recommend memorizing the tangents. So √3 over 3, 1, and then √3. So that means right here is going to be the -√3. So that's at the angle 5 pi over 3. But since we cannot enter these quadrants, we need to make that a negative angle. So that's going to be negative pi over 3 for the inverse tangent of -√3. Okay. So now this one is a little bit different, but it's not any harder. So all you have to know, so you need to work from the inside out. So start with the inside, which is sine of 3 pi over 4. Start with that and find that angle. And then you can go sine -1 of whatever that was equals, and that's going to be your answer. Okay. So the sine of 3 pi over 4, remember for regular sine, we can go into any quadrant. So we need to find 3 pi over 4 right here. And the sine of that, remember cosine, and sine, the sine of that is going to be square root of 2 over 2. Okay, so now we take that and plug it in right there, square root of 2 over 2. Now for this, you may be thinking, well, isn't theta just going to be 3 pi over 4? No, because we cannot use these two quadrants for the inverse sine. So we must find where sine equals square root of 2 over 2 in the first and the fourth quadrants. And the only spot where it's going to equal that is pi over 4. And since this is the angle without entering these two quadrants, we can keep that angle of pi over 4. So that is what the inverse trig functions are and how to use them.